In today's video, we'll look into the holographic principle, a theory that might not only redefine our understanding of the universe, but also challenge our very perceptions of reality. By the end of this video, you will have a clearer understanding of what the holographic universe theory suggests, why it matters, and how it came to be considered a plausible scientific hypothesis. The holographic principle suggests that all the information which makes up our 3D reality, everything from your morning coffee to the stars in the sky, is actually contained on a two-dimensional surface on its boundaries. Imagine that! What we experience as 3 dimensions could actually just be a kind of projection from this two-dimensional shell. This idea isn't as new or as far-fetched as it might sound. It originated in the 1990s with theoretical physicists Gerard 't Hooft and Leonard Susskind. They proposed that this principle could be a significant and integral part of understanding gravity and quantum mechanics on a deeper level. The theory was inspired by black hole thermodynamics, which suggests that the informational content of all the objects that have fallen into a black hole can be entirely contained on the surface of its event horizon. To lay people, the holographic principle might sound like science fiction, but it is grounded in very real, cutting-edge science. It builds on the foundations of quantum mechanics and cosmology, two fields that deal with the universe on incredibly small and vastly large scales. Quantum mechanics and cosmology traditionally operate in very different realms. However, at the point where they intersect, they suggest a universe that is far stranger and more interconnected than we ever imagined. Quantum mechanics shows us a world where particles can be in multiple places at once, can disappear and reappear seemingly at will, and where the act of measuring or observing actually affects the physical processes that are taking place. Meanwhile, cosmology has shown us a universe that is expanding and evolving, with phenomena like black holes and dark energy. When theorists like 't Hooft and Susskind looked at black holes, they suggested a radical idea: that all the information about the objects swallowed by a black hole could actually be encoded at its edge, on its event horizon. This led to the suggestion that our entire universe might operate on a similar principle, that the vastness of space and all the objects in it might just be a projection from a distant boundary. To support this mind-bending idea, several key experiments and lines of research have provided backing. For example, studies involving deep space observations and particle physics experiments at facilities like the Large Hadron Collider have hinted at the interconnectedness and potential two-dimensional source of our three-dimensional experiences. Moving beyond the theoretical underpinnings, let's consider the tangible evidence that supports the notion of a holographic universe. Recent advancements in technology and astrophysics have allowed scientists to observe phenomena that seem to back up this theory. One of the most significant pieces of evidence comes from the analysis of cosmic microwave background radiation, the afterglow of the Big Bang. Detailed observations of this cosmic radiation have shown irregularities that are best explained by the holographic principle, suggesting that this ancient light pattern itself could be a projection from a simpler two-dimensional state. Further support comes from the behavior of gravity and black holes. Theoretical models and observational data increasingly suggest that the information contained within a black area, essentially all the matter that ever fell into it, does not disappear, but is rather stored at the two-dimensional surface of the event horizon, in line with holographic theory. This remarkable insight not only supports the holographic model, but also aligns with the laws of quantum mechanics, which argue that information can never be lost. Expert opinions from leading physicists around the world are increasingly lending weight to this model. Renowned theoretical physicists have publicly discussed their findings in various conferences and papers, highlighting experimental results that consistently point towards a holographic interpretation of the universe. These findings are not just academic. They represent a potentially paradigm-shifting understanding of our cosmos. The implications of living in a holographic universe are profound and far-reaching. If the holographic principle is true, it could revolutionize our understanding of the universe in several ways. For science, it offers a new framework for understanding how information and reality are interconnected. This could significantly affect fields like quantum computing and theoretical physics, possibly leading to new technologies that we can only begin to imagine. Consider the possibilities in technology and everyday life. Technologies that leverage quantum mechanics, such as quantum computers, might suddenly become more efficient or even take new forms based on holographic data storage principles. In medicine, our understanding of the brain and consciousness could be transformed if we consider them as holographic systems, potentially leading to breakthroughs in treating neurological disorders and understanding mental process. If our perceptions of a three-dimensional world are merely holographic projections from a two-dimensional reality, this raises philosophical and existential questions about the nature of reality and our place within it. Are our thoughts, emotions, and conflicts also projections of this kind? What is real might be far different from what we perceive, challenging our basic assumptions about life and our sense of identity. The holographic principle suggests a new way of looking at everything, from the art we create to the ways in which we understand our spirituality and our interconnectedness, not just with each other, but with the cosmos itself. Let's examine some of the criticisms and challenges this theory faces. Critics argue that while the theory is intriguing and mathematically plausible, the physical evidence remains indirect and can often be interpreted in various ways. For example, the irregularities found in the cosmic microwave background can also be explained by other cosmological models without invoking holography. Some physicists point out that the holographic theory, while elegant, does not yet offer specific predictions that can be experimentally tested differently from existing theories of quantum gravity and cosmology. This lack of testable predictions makes it difficult to scientifically validate or falsify the holographic view, leaving it more in the realm of theoretical possibility rather than empirically supported fact. To address these criticisms, proponents of the theory are working on ways to derive more direct, observable consequences that could be tested with future technology. They argue that skepticism is a healthy part of scientific progress, pushing the theory to evolve and become more robust. Additionally, let's clear up some common misconceptions. The holographic universe theory does not imply that our daily lives are fake, or that the world is an illusion in the traditional sense. Instead, it suggests a new way of understanding the underlying architecture of the universe and how we perceive space and time. Shifting from scientific critiques to philosophical implications, the holographic principle invites us to rethink our notions of reality and existence. If the universe is indeed a holographic projection, what does this say about our perception of space and time? Are they merely constructs of a deeper, more fundamental reality? These questions intersect with age-old philosophical inquiries into the nature of reality and perception. Philosophers have long debated the relationship between appearance and reality, and the holographic principle adds a fascinating modern twist to this debate. It challenges us to consider the possibility that what we see and experience is not a direct reflection of the most fundamental aspects of the universe, but a kind of interface or rendering. This theory resonates with various philosophical and spiritual traditions that suggest the material world is an illusion or a secondary aspect of a deeper reality. Such views are found in Eastern philosophies like Buddhism and Hinduism, which speak of the material world as Maya, an illusory aspect of the universe meant to be transcended. The holographic principle could potentially bridge the gap between science and spirituality by providing a scientific framework that aligns with these philosophical and spiritual insights. It suggests a universe where all parts are fundamentally interconnected at a deep level, echoing the mystical experiences reported by many spiritual traditions. While into the profound implications of the holographic universe theory, I invite you to reflect on how this idea might change your view of reality. Imagine if the very fabric of your day-to-day experience is just a small part of a much larger, more complex tapestry that is beyond our typical understanding of space and time. How does this shift your perspective on the problems you face, the dreams you pursue, or the mysteries of life you ponder? I encourage you to engage with these concepts not just intellectually, but personally. What would living in a holographic universe mean to you? How might it influence the way you think about your connection to the universe and other people? Share your thoughts and questions in the comments section below. Let's start a conversation about what it means to live in a universe that is far more interconnected and mysterious than we've ever imagined. If you're intrigued by these ideas and want to explore further, consider diving into related topics such as quantum mechanics, black hole theories, and philosophical existentialism. Each of these areas offers further evidence and insights that enrich our understanding of the holographic principle. To recap today's exploration, we've journeyed through the concept of a holographic universe, from its scientific underpinnings and the evidence supporting it, to the criticisms it faces and the profound philosophical questions it raises. This theory not only challenges our traditional views of physics and reality, but also provides a tantalizing glimpse into how everything in the universe might be much more connected than we ever realized. Whether you're a seasoned scientist, a curious philosopher, or just someone fascinated by the mysteries of the universe, the holographic principle invites you to reconsider everything you know about reality. It prompts us to think about the universe not just as a vast expanse of space, but as a complex, information-rich field that is fundamentally holographic in nature. While we conclude, I want to thank you for joining me in this thought-provoking exploration. If you enjoyed this video and want to keep up with more content that challenges the boundaries of conventional science and philosophy, don't forget to like, subscribe, and hit the notification bell. Your engagement helps us bring more such insightful content to you. Remember, the universe is as strange and wonderful as our capacity to understand it, and possibly even more so. Keep questioning, keep wondering, and keep looking beyond the horizon of conventional understanding. Thank you for watching, and until next time, keep pondering the mysteries of the cosmos.